Chemical formulas can be also used as conversion factors. So this is a concept that somehow stumps many students. And I think some of these things, you kind of set yourself up, you're expecting it to be hard, and so then you actually make it hard. When you can actually do the same thing with things that you're familiar with. And so I know you can do it with molecules and atoms, you just think you can't. I mean, if we look at this clover, how many leaves on the clover? It's not a trick question. 3. One clover has 3 leaves. That's a conversion factor. So, how many leaves are on 14 clovers? Can you figure that one out? Sure. We just take 14 and multiply by 3, right? You know what to do because you can visualize that. You could see it. This is how it works out with the units. There are 3 leaves on one clover. I have 14 clovers. If I multiply by 3 leaves per clover, I come up with 42 leaves. It would be silly to divide by 3, wouldn't it? That wouldn't make any sense. We're going to do the same thing as this with chemical formulas. The formula is going to give us the relationship between number of atoms and molecules. So, I don't like spiders, but there's a big old spider. Ah! Big spider. 8 legs on a spider. How many legs on 2 spiders? 16. There's a chair. This chair has 4 legs. If I had 3 chairs, how many legs? 12. So we can do that. Here's a water molecule. Each water molecule has 2 hydrogen atoms. If I have 3 water molecules, how many hydrogen atoms? 6. See, you could do it. That's all it is. Let's find the number of moles of carbon in 2.3 moles of lead carbonate. Let's look at this formula. One mole of lead carbonate. We're going to get a conversion factor out of this. It's going to relate moles of carbon. So if we're looking in this formula, how many carbons are in the formula? 2. Inside the parentheses, we have 1 carbon, and there are 2 of those groups. There's 2 carbons in the formula. So if we had a dozen of the formula, we would have 2 dozen carbons, right? If we have a chemist's dozen of formulas, then we have 2 chemist's dozen of carbon atoms. Does that make sense? This is just like 2 legs on a person. That's all it is. Relationship between moles of this and moles of one of the elements. So this conversion factor comes directly from looking at the formula. Here we're looking for moles of carbon in 2.3 moles of that. 2.3 moles of lead carbonate. And we want to know moles of carbon, so we need to divide by moles of lead carbonate. Actually, lead 4 carbonate. PbCO3 too. So the units cancel out. There are 2 moles of carbon for 1 mole of this. 2 moles to 1 mole. I think that's going to be 4.6. Yes?
You got that C number from the number of carbons that's in lead carbonate?
Yeah, from looking at the formula. And this is something we went over real briefly I believe, earlier, looking at this formula. That formula has 1 lead and 2 carbons and 6 oxygens. Okay? And so we could make a relationship of lead atoms, or moles of lead, to moles of lead carbonate. It'd be 1 mole of lead per mole of lead carbonate, 2 moles of carbon, or 6 moles of oxygen per mole of lead carbonate. It's conversion factors that are just kind of hiding, they're lurking in that formula. Any questions? Find the mass of aluminum in 19 grams of aluminum chloride. 19 grams. We want mass of aluminum. So we've got grams of AlCl3. And we want grams of aluminum. Do we know a relationship between grams of aluminum chloride and grams of aluminum? Have we talked about anything like that? No, we haven't. We've been talking about the periodic table. And there's numbers on the periodic table, and what do those tell us? The mass of a mole of something, right? So if we're just thinking about this guy, what could we figure out about him from the periodic table? Could we figure out the mass of 1 mole? Yeah. So 1 mole of aluminum is equal to 26.98 grams of aluminum. Could we do something similar for aluminum chloride? Could we calculate the molar mass of aluminum chloride? Yes. Yes, we can. We can do it. AlCl3, 1 aluminum, 3 chlorines. So the mass of 1 mole of aluminum, which is 26.98 grams, plus 3 times the mass of chlorine, calculator keeps turning off. Lazy thing. $133.33 grams of AlCl3. They're overlapping each other, I'm sorry. And that is equal to 1 mole, right, of aluminum carbonate. It's not carbonate, it's chloride. Aluminum chloride. You with me so far? These are seemingly random things I'm saying, hey, let's do this. But we've done these just today, right? Okay, so here we have something that talks about grams of aluminum chloride. So this would allow us to convert from grams of aluminum chloride to moles of aluminum chloride, right? We did some problems like that. We're trying to figure out what steps do we need in the middle here. So we could go to moles of aluminum chloride. And this guy over here relates grams of aluminum and moles of aluminum. If we knew how many moles of aluminum we had, we could find the grams. So we can work backwards over here and say moles of aluminum could come before that. With me, we're kind of working into the middle. Is there a relationship we can figure out between moles of aluminum chloride and moles of aluminum? Yeah. We use, it's hiding in this formula. 1 mole of aluminum chloride has how many moles of aluminum in it? In this formula, how many ALs are there? 1. 1 mole of aluminum. There's the missing conversion factor. I'm going to switch colors a little bit, so hopefully, that shows up as different. So 19 grams is what I was given to start with. 19 grams of aluminum chloride. And we've got grams of aluminum chloride and grams of aluminum, and so we can't just use grams anymore, because we need to know grams of what. So we have to specify. So 19 grams of aluminum chloride, and this is our path. Grams to moles of aluminum chloride to moles of aluminum to grams of aluminum. And after a while, the word aluminum sounds really weird. Just say it over and over again. Aluminum, aluminum, aluminum. Grams of aluminum chloride to moles. So my unit in here is moles of AlCl3. You see what I'm doing? And then this one is next. Moles of aluminum. And then at the end, I've got grams of aluminum. Grams to moles to moles to grams. This unit is what I want to put down here. I want all these guys to cancel out except for this last one. So I'm going to put grams AlCl3. And those cancel out. And then I'm going to put moles AlCl3. And then I'm going to put moles of Al down here. I'm following the units. I've got all these conversions in here. Okay, this one is 1 mole of AlCl3 equals 1 mole of Al. So that's this guy right here. And it happens to be 1 to 1. Write it in there anyway so that the units work out. It's not always going to be 1 to 1. And then I've got this relationship over here. Moles of aluminum to grams of aluminum. That takes care of this one. It's 1 mole of aluminum and 26.98 grams of aluminum. And then I've got this guy. Grams of AlCl3 to moles of AlCl3. So over here, again, it's 1 mole, and the number goes with grams. Start at the left, go to the right, multiply by the top, divide by the bottom. 19 divided by 133.33 times 26.98. And this should have 2 significant figures, so that's all I'm going to write down, 3.8 grams of aluminum. Is that a reasonable answer? I have 19 grams of the compound, and there are 3.8 grams of aluminum in the compound. What if I had come up with 38 grams of aluminum? Would that be possible? No. That's like saying there are 25 boys in a kindergarten class that only has 12 students, right? I saw a great t-shirt. 4 out of 3 people have trouble with fractions. It just cracks me up every time. Any questions about this problem? Nope. Okay. So relationships like this are inherent in the chemical formula. They're hiding in the chemical formula. 1 mole of CCl4. Cl4, there's 4 moles of chlorine in there. And this allows us to go from moles of compound to moles of element, or from moles of element to moles of compound.